pull up my here real quick. Just look at it yet?
Yeah, we looked through it a little bit. I think we got number 1 figured out. Know a bit of how to do number 3, but I'm kind of confused on number 2.
Okay. Here really quick. So 1 is just you multiply it by the 1s and the 0s, right?
Yeah.
So you do like 1, -3, -2,
3, 1,
3,
2, 5,
1.
Yep.
2, 2, 1.
Oh, I guess it's 0 because there's okay, yeah. So it's 1, 0, -3,
Yep.
-2,
Yep.
3, 1, 2, 2, 1, 4. And that's what you just multiply all those by 1s and 0s.
Pretty much, yeah.
So it's 3 by. How does that work? It's 3 by 4. Just 0 or 1, 0, 0, 0, 0, 1, 0, 0, and 0, 0, 1, 0. It's not an exact. Or do you even put those? Wait, do you even put them? Is that right? I not understanding it.
I'm writing it down.
Yeah, I have no idea how this makes sense because when I'm looking over like the steps, it just doesn't make sense that it should work out. But
It does.
it because
Weird.
you go by like the rules of like you multiply the first row by 3, then you're going to subtract 2 from row, then you're going to subtract that from row 2, then you're going to multiply first row by 2 and subtract it from the third row. Then you're
Oh wait, yeah. So I'm thinking about a different thing. So it's 0, -3, and that's -2, 5, 4. So you're supposed to get 1. What is it like 1, 0?
Yeah, so after you do that first step, you're going to come out with the rows of 1, 0, -3, -2, then 0, 1, 7, 11, and then 0, 2, 7, 8. And that's the first
Wait,
step.
how would you do that again? Because it was 1, 0, -3, -2.
Yep.
But what do you're trying to.
Yeah, so what you do is the first few steps is you're going to multiply the first row by 3, and then you're going to subtract it from the second row.
So multiply everything by 3. Why?
Or wait, by 3 or so for the third. 1 sec. I did this early and I can't remember how I did it. I just wrote down 3, and I don't know if I mean 3 or third multiplied by the third row. Damn, what did I mean by that?
She's trying to get it be 1, 0.
How did I do this? Dang it, how did I do this? I think what I did was I think I multiplied the first row by the third row, and then I subtracted that number from the second row.
Okay.
That was the first thing I did. I think after that I multiplied the first row by the second row and subtracted that from the third row. Yeah, I think that's working out. Looks like that's the right math. Yeah, so that was the first step. Then the second step was you multiply that new second row by 2. Yeah, then you multiply that second row by 2. Don't remember why. But you multiply the second row by 2, and then you subtract that from the third row.
Okay.
Which ends up with your matrix after that step being 1, 0, -3, -2. 0, 1, 7, 11. 0, 0, -7, -14.
And divide. Yeah.
Then you divide the third row by -7. Can't remember why, but I know you do. Should have done this a little bit closer to when we met so I could describe why. Then afterwards, you multiply the third row by 3, add it to the first row. That gets rid of your -3 on the first row. Then you multiply the third row by 7, subtract it from the second row, and that gets you your matrix that you want to see, which is the 1, 1, 1 going straight down the middle and diagonal, which is your goal with these Gaussian eliminations. Then if you want to, you can always check by throwing 4 back into your equation. That should give you your answers, or your different answers into each of the equations. That should give you the right answers.
Right. Which one switch?
Yeah. So I ended up getting 4, -3, and 2.
Already has the ones down the middle, so you just need to get the zeros, right?
Yeah.
So you said you multiplied it by 3. Did it from the bottom. Okay. And just because I'll have to look at it. Just to number 2.
Yeah, number 2. That one's kind of confusing me by what they're.
If you were given any matrices that are the same size, it's called matrix A and matrix B times A plus B equal K times A plus A times K times B. Any constant K.
Here, I'll check real quick with just an easy 2x2 matrix and see if those equal out to be. Any-
Two.
Yeah, for number 2.
I'll matrix in K. K A plus K. Oh, so it's asking if without the parentheses, would it be the same if K was constant?
Pretty much, yeah. I'm double checking right now to see if it is. Just
Technically,
with like a,
right? Because it's just but we have to show an example.
I'm trying to think of whether or not it is one. So we should do that, but that then 2 gives 2, 2. Good. 8s and 12s. Yeah, you do.
What's that?
Yeah, you do get That will be the same thing. I just did one pretty easy. I just did my first matrix was 1 2 2 1, and then my second matrix was 3 4 4 3, and then I just multiplied them by added them together, then multiplied it by 2, and then I did the other way around, and it equaled out to be 8 12 12 8 for both of them. So as long as that applies for all of them, but I think it should apply for all of that.
What did you do?
So I just plugged in. So I just got a matrix out real quick, and then all you do is you just plug in for the first matrix, something really simple. So I just did 1, 2, 2, 1 in the rows, and then my second matrix was 3, 4, 4, 3. Any numbers will work, I think, but just wanted to give some variance. And then all you do is, since it's just a matrix, you have your two options. You can either add the matrices together, which if you add the matrices together first, they'd end up being 4, 6, 6, 4. And then if you say that your constant k is 2, you'll end up getting 8, 12, 12, 8 for your final matrix. But if you wanted to do it the other way around, that's pretty easy as well, because you have your first matrix, which is 1, 2, 2, 4. You multiply that by 2 first, and you end up getting a new matrix that's 2, 4, 4, 2. And your second matrix, matrix B, is going to be 6, 8, 8, 6. You add those together, and you end up getting your I think it should be getting those. Let me see. Where am I at? Yeah, that should be right. Did I mess up? I might have messed up. Oh, that's right, yeah. You end up getting 8, 12, 12, 8. Again.
Okay.
So if you pick an easy matrix that's just with small numbers, this is not too bad of a question by the looks of it.
Gotcha.
I'm not entirely sure about the next part of it. I'm trying to understand what they're asking.
Should be multiply.
That second part, I don't know what they're talking about, though. Yes, I'm just kind of confused when they say M times N matrix and N times P matrix. Are those specific matrix names that I'm supposed to know?
Good question.
Because I don't remember ever reading about anything that was an M or N or P matrix.
Nó không có ngon, một em đi lên nghe được. Thanh lý mà.
Yeah, I have no idea what they're asking that second part there because I don't know what they mean by an M, N, and an N or a P matrix. I'm gonna pull up the book real quick and see if I can find anything on that.
Okay.
Yeah, I don't get the second part of that question. Makes sense.
Okay, I think I found the page of the book that's kind of talking about it. Maybe. So go to page, if you go to the e-text,
Okay.
it looks like it's, I'm not entirely sure, but the first place that I actually saw those letters being used again was on page 646.
$6.46.
Yeah, 646.
And
What?
maybe. Hmm.
I have no idea what they mean by those matrices still exactly.
No,
Just
no.
saying that if you multiply an M by an N and an N by a P, you'll get an M times P. What they mean by those matrices? I just feel like they're making up terms almost.
Yeah, it's a little weird. That's N.
We'll go back to the previous section and see if there's, or previous part pages and see if there's anything about M and P exactly.
Entry. Hmm. Yeah, it's basically just saying we go to multiply the MN matrix with the NP.
I don't know if you're talking about specific matrix sizes almost in this.
Yeah.
I think they're just talking about that idea of blank by blank in terms of say whatever you want to is M and whatever you want to is N. So, like, M can be equal to 2 and N can be equal to 3. So that'd be your 2 by 3 matrix. And then it would be a 3 by 4 matrix as your next matrix. And yes, it looks like you can because that's the same exact question. If you're on page 646, that yellow box. So your size of your next matrix would be M times P, and that's it. That's the whole answer to that question.
So I'll just put that then. Like it would be an M times P.
Yeah, I think it's yes and M times P because that's the same exact question that they're saying there in that definition matrix multiplication box near the bottom on page 646. At least unless I'm just not being able to read, that is the same exact question.
Yeah.
So I think that's the answer to it.
Just the
It's going to be M times P. And that's it.
yeah, maybe it has nothing to do with the other question, really.
I don't think so. I think it's just
Size would be just a 4 by or a 2 by 2. Is that 4?
yeah. So like question 2, that first one's going to be a 2 by 2 if we just keep it as a 2 by 2 to make it easy. But for part A of question 2, I don't think it matches up with anything on question 2 at all, other than the fact that we're dealing with what's the rules for multiplying matrices.
Right. Yeah, that sounds good to me.
Okay.
Okay.
Sweet. Okay, where are you at? There you are. Okay, so question 3 is infinite geometric series.
number 3, like
Yeah, that one's kind of a mess. Let's see. It seems like there's an easier way than having to do the infinite geometric series. So I've seen other people do this when I've been kind of looking at the homework and stuff, that pretty much what you need to do is you just take that fraction that you have, or that decimal that you have. In this case, it's 0.18 repeating. You put 18 let's see if I got this right. Yeah, it should just be, I think it should just be 18.18181818 blah, 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 all the way down. Is equal to 100x. And then you subtract the two equations. So the first equation was x is equal to 0.18 repeating. The second equation is 100x is equal to 118.18 repeating. Subtract those two equations, and I think you should get
okay.
99x is equal to 18. And then you just divide the 99 out, so you get 18 over
99.
99.
That's 2 over 11 if you break it down. Yeah, that is 2 over 11. Yeah, 2 over 11 is 0.181818 repeating.
Okay. That was easier than I thought it was going to be.
Yeah.
Sweet.
Interesting.
Okay. Sweet. Is there any other parts of that question, Ola, or is that the only part of that question? Oh, no, that's it for it.
Okay, yeah. Let me see.
Nice. Okay, well, I think that's it unless we have any other questions, and I think that's it for our meetings for the semester as well.
Yeah, next week just the finals. That's it.
Okay.
Oh, well, that's nice.
Yeah, semester's been hot, been tough.
Mm-hmm.
Ugh, yeah. All right. Well, I'll submit the video, and I think Kevin's got the.
I wrote everything down, so we good. I'm just gonna turn it in.
Okay. Sweet. Okay then. If you guys have a good rest of your semester, good luck with finals and everything.
Good luck, guys.
Thanks.